At the bottom left of this vertical image are the thickest regions of brown and rusty red gas and dust known as pillars. There are many layers of semi-transparent gas and dust overlaying one another. A peak rises about a third of the way from the bottom in the left corner and becomes far darker brown with two bright red areas toward the tip where stars are forming. The light brown dust becomes more diaphanous about halfway up the screen, ending in a softer, medium brown peak toward the left center. There's a slight gap in the dust, which allows the blue background to come into view clearly. About 60% of the background in this image is set in shades of blue and littered with tiny stars that are primarily yellow, but many are also blue. The brown pillars continue, taking the shape of a shoulder at the base, with three prominent columns rising from it toward the upper right. The top left pillar is the largest and widest. The second one to its right is slightly smaller, and the third significantly smaller. The peaks of the second and third pillars are set off in darker shades of brown, but also appear to have red outlines. The second pillar has a lava-like red area at its top left, and a dark arch that looks like an upside-down L halfway down. The third pillar is largely set off in dark brown shades, but also very bright red all along its edges. The largest bright blue stars in the background, toward the top center, have 8 bright, long diffraction spikes. At the bottom left, in front of layers of brown dust, is another large star with 8 diffraction spikes, but it is set off in orange shades. NASA's Hubble Space Telescope made the pillars of creation famous with its first image in 1995, but revisited the scene in 2014 to reveal a sharper, wider view in visible light, shown above at left. A new, near-infrared light view from NASA's James Webb Space Telescope at right helps us peer through more of the dust in this star-forming region. The thick, dusty brown pillars are no longer as opaque, and many more red stars that are still forming come into view. While the pillars of gas and dust seem darker and less penetrable in Hubble's view, they appear more diaphanous in Webb's. The background of this Hubble image is like a sunrise, beginning in yellows at the bottom, before transitioning to light green and deeper blues at the top. These colors highlight the thickness of the dust all around the pillars, which obscures many more stars in the overall region. In contrast, the background light in Webb's image appears in blue hues, which highlights the hydrogen atoms and reveals an abundance of stars spread across the scene. By penetrating the dusty pillars, Webb also allows us to identify stars that have recently or are about to burst free. Near, infrared light can penetrate thick dust clouds, allowing us to learn so much more about this incredible scene. Both views show us what is happening locally. Although Hubble highlights many more thick layers of dust and Webb shows more of the stars, neither shows us the deeper universe. Dust blocks the view in Hubble's image, but the interstellar medium plays a major role in Webb's. It acts like thick smoke or fog, preventing us from peering into the deeper universe where countless galaxies exist. The pillars are a small region within the Eagle Nebula, a vast star-forming region 6,500 light-years from Earth.